Okay, Google just released its agent-to-agent protocol. But with its launch, there are some big questions which arise. Like, what about MCP? Like, does A2A replace MCP? Is there an overlap? And if not, when do you use what? Well, in this stream, we are going to pit A2A against MCP and see what their differences are, take a good example to highlight some use cases, and finally arrive at a framework which helps us decide when to use what. Let's get started. I think the best way to compare any frameworks is by looking at an example, right? And we already saw this, so let's just go through it again. It can be a quick recap, okay? Let's say that I'm a human, yeah, a cute little guy. That's me, yep, right here. And let's say I'm supposed to finish a project by the end of the week, right? And I keep all my project stuff in Notion, and I keep all my calendar in Google Calendar, right? So my projects and my tasks are in Notion, and everything else is in Google Calendar. And I just want to make sure that all my tasks for a particular project gets done by the end of the week. Why? Because my manager is annoying. So yeah, need to finish it by the end of the week, and we start with a request. We tell our personal assistant that, hey, you know what, schedule all the tasks for project A by the end of this week. Now, the assistant will go ahead to Notion and will be like, hey, give me all the tasks for this project with estimates. Notion will give me back a response. It will say that, hey, you have 2 tasks. Task A is 1 hour, task B is 4 hours. Then the assistant goes ahead to Google Calendar and goes like, hey, you know what? Can you now schedule these tasks in this week itself? I have 2 tasks. Just be kind to me. So obviously, Google Calendar tries its best, but unfortunately, we don't have enough space in our calendar. We just don't have a 4-hour block free. I'm a busy man, guys. So yeah, we get a response back. Now, what do? So let's say the assistant takes a call that, hey, can we break task B down? So instead of scheduling it in one shot, can we break it down into subtasks? So we go to Notion and we say, hey, can we break this task further down? And Notion goes like, oh, you know what? We actually can. And then it gives a list of subtasks or something as well. And then we go ahead to the calendar and be like, hey, can you schedule this instead? And it says, hey, I scheduled it. And while all of this was happening, because our agent looks like this, our agent is impatient. And in my previous video, users are monkeys. They're impatient beings. So you need to make sure, you need to comfort them that, hey, something is happening, so they stick along. They just stay with you. They don't leave you. So what you do is, as things are happening in this agent, you need to start giving it updates. Right? You need to give it updates to build a good user experience that, hey, you know what? I got 2 tasks back. Oh, wait a minute. Or maybe you could have an update saying, now I'm trying to schedule it. Maybe there could be another update to schedule it. Maybe we should add that. Trying to schedule now. This should come before scheduling. Don't worry about the timing in the sequence diagram. It's all over the place, okay? But you get the gist, right? You're giving your user updates on what is happening, so the user is in loop. This will help the user know that, okay, my agent is actually doing the right thing, which is kind of important. And not just that. I mean, you could even have some human in loop scenarios, right? Where you could be like, okay, we want to break a task down. And Notion was like, yeah, you can break this task down. But what if Notion doesn't know how to break the task down? What if it comes up with incorrect subtasks? Maybe we want to show the user an input, hey, we want to break task B down. Can we do that? And the user goes like, yeah, cool, you can do this. And then you schedule it. So you have like a little human in loop scenario going on in here. That's how the real world operates, right? Your agents might screw things up, or some things might not be possible. So you need like follow-up questions. And then you also want to give feedback to the user. You also want like human in loop scenarios and all that funny stuff. That's how real agent interaction works, at least in the real world, right? This is the example we're going to use to start comparing things. Sounds good? You guys are with me? Okay, one important point. I'm going to skip some low-hanging fruits. Like I'm going to skip authentication. I'm going to skip service discovery. I know for some people, this was like a big deal that, oh my God, MCP doesn't support auth, or MCP doesn't have a service discovery API or whatever. Those are not that big problems because, I mean, you could just shove in tokens in the headers and things like that, like you do with REST APIs anyways. Those were not that big problems, at least according to me. So we're going to skip it just, for clarity's sake. A2A does support authentication and authorization. And in fact, it just uses the Open API authentication. Again, Open API, not OpenAI. It's Open API. So it uses the Open API's authentication specification, which essentially says the agent will explicitly mention that, hey, I support basic authentication, which is username password. I support bearer token authentication. I support OAuth2, blah, blah, blah. So the agent will be explicit about what authentication it supports, but you still like have to give it up front. I know this is on MCP's roadmap as well. Not just that, A2A also has a discovery document. So it actually says that, oh, you know what? If you want to discover agents, you can do it using well-known format, which we usually use like sitemaps and things like that. You could also have like an API. They clearly mentioned that, hey, we don't have a protocol for the registry yet, but if you need it, then let us know, because I agree this is not that important. You can make it yourself. Why do you need a protocol for these things? But okay, that's the point. These are low-hanging fruits. These are things which do not really impact functionality that much. I mean, they're important. You have to implement them, but I'm going to skip those things. So let's talk about the comparison. And how are we going to do that? We're going to make a table. Let's try to do this. I think this is where we should start. Okay, so the way we're going to do this is we're going to write A2A here. We're going to write MCP here. And then each feature we'll write here. So against every feature, we'll see what A2A does for it, what MCP does for it, right? Because on the surface, it seems like there's a lot of overlap, but it's actually not. Spoiler alert, they're very different protocols for very different purposes. Yeah, cool. So the first thing I want to start with is capability discovery. So how do you discover what is the possible options or what are the different functionalities which an A2A server or an MCP server give you, right? Like, how did you know in this example that, hey, you can get these tasks? Like, you can even ask it for tasks. While asking for tasks, you can also ask for estimates. How do you know those things, right? So there has to be some way to discover what capabilities or what functionality does this guy give us. Yeah, that's kind of important. Yeah. So for A2A, we have something called skills. The way we discover capabilities in A2A is through skills. The way we do it in MCP is through tools. Now, technically, MCP does have resources and prompts as well. I'm just going to skip those guys. I don't know who's using it. But yeah, we're just going to limit our thing to tools and skills, because I think that's where a lot of the mix-up would happen. Prompts and resources is like a completely different thing. So I'm just going to skip those things. So in A2A, you have the concept of a skill. In MCP, you have a concept of a tool. So we already saw an example for A2A, but let's go through that again. Let's just look at discovery first, and then we can say who can use it, right? So the first, how it works with A2A, you have something called the agent card. And this agent card is on steroids. This is good stuff. This is what you can discover. So every agent publishes this card. It's just a JSON object, and it declares that, hey, this is my capability, right? So you can clearly see that, okay, as input, it supports plain text, and as output, it can do plain text as well, and it can even create HTML code as output. In capabilities, it says it can support streaming, so it supports streaming responses. It supports something called push notifications. We won't talk about push notifications. See the previous video for that one. Now, this is the most important thing. Oh, there's also one more thing. There's something called task state updates or something like that. That's also a very cool capability. So there are 3 capabilities right now in the spec. Again, check out the previous video for all this. Now, this is the cool stuff. Unlike MCP, A2A has skills, right? This is a Google Maps agent, right? So the skill is route planning. It can do route planning. It helps planning routes between 2 locations. Now, this is a very generic description. What does it actually mean? It's got examples right here which says, plan my route from Sunnyvale to Mountain View. Oh, so route planning means actually planning my route from Sunnyvale to Mountain View. Okay, interesting. What does route planning mean? What's the commute time from Sunnyvale to San Francisco at 9 a.m.? Oh, it's being so specific here. So not only can I use it to plan my routes, I can also use it to get the time for the routes. Like, how much time does it take? Maybe I know the route. I just want to know how much time would it take for a particular hour, something like that. You can do that too. All right, cool. I'm learning new things. And then you can get turn-by-turn direction. So one route could be just, hey, here to here, and maybe another could be a turn-by-turn route where you get like a very comprehensive thing like, okay, go left from here, go right from here. The point is, it's actually telling you very high level, broad capabilities or queries you can ask this agent, right? And it's very natural language focused. I think that's a really important point. Again, I don't know how to best describe this. I'm so sorry about that. But in A2A, skills are really broad capabilities with some examples on how you can mess around with it. There is intelligence on the back end, which is trying its best to take your query and give you an answer on it. So under the hood, technically speaking, this one thing could require 10 tool calls. Maybe. I don't know how many tool calls would Google have to do to answer this. I don't know how many tool calls would Google have to do to answer that. The point is, I just give it questions in natural language, and I don't have to worry about the breaking down of questions and things like that. I can just give it questions and give me some example questions as well. Thank you. And obviously, you can have as many skills as you want. So that's how you define skills in A2A at least. Okay. In MCP, you do tools. So how would it look like in MCP? Okay, so this is how you do it in MCP. Oh boy. So you define tools. There's a very fixed scope of what a tool is. So in this example, the tool is calculate sum. There's a description. There's a very strict input that, hey, for the input, you have to give me a number, you have to give me another number, and both are required. I mean, it doesn't describe the output, but it describes the input. It's very, very fixed, right? And all you can do is you get an API saying, give me all the tools, and that will essentially give you an array of these tools. So you could see there's a tool for calculate sum, there could be a tool for add two numbers, it could be for everything. So again, going back to this example, which we had here, if this was an MCP server instead of Notion agent, so instead of getting skills back with example queries you can ask, you would get a list of tools back, and one tool would be get tasks with estimates. One tool could be just get tasks, right? One tool could be get estimate for task, right? So those would be tools. You would have 5-6 different tools, and somebody would have to decide what tool to call. A2A is not explicit at all. A2A just gives you a list of skills, and you just give it a query. You don't even have to say whether I want to use skill 1 or skill 2. You just give it a query and the agent will figure everything out by itself. That's wild, right? In MCP, very well defined. In A2A, it's a little bit more broad, right? Some clarifications. I don't want to make you think that, wait, that A2A is more broad and MCP cannot be broad. MCP can be broad as well. Let's just drill down on this a little bit more. Okay, so basically what I'm suggesting is in MCP, you have like get tasks, right? And then for get tasks, you could take a project as an input and you give some output, right? That's an example of how the tool would look like. And technically what I'm saying here, that this will only have one function. Let's call it send task. And this could be anything. This is just a message, which could be any. And by any, I mean, obviously there's some protocols around it. It could be a string, it could be an image, it could be a lot of different things. But that's what I'm saying, right? But technically in MCP as well, you could have the same kind of a function, right? You could technically just have one tool in MCP which says send task, and the message could be any. It could be string, it could be binary, it could be anything. And now you have the same kind of API for both of them, right? So A2A is kind of like MCP with a single tool. That's what I'm trying to highlight. A2A is like MCP server with a single tool where you just take a message as the input, and the message could be anything. It could be natural language string, it could be structured, it could be a JSON object, it could literally be anything. However, most people will use MCP more like this, like get tasks, create task and stuff like that, right? Create task, and maybe here you have a task as well, whatever. You get the point, guys. Again, A2A is like an MCP server with just a single tool, all right? However, in MCP, the spec currently only has a description. So the only way you can describe what this tool does is through a description. So you would have to write like a really huge description with a lot of examples. So it would become a very difficult process to do it. I'm saying you can do it, but it's really complex. So having a single tool which can do everything in MCP is going to be a little bit hard because your description is going to be bonkers. It's going to be really hard. Instead, in A2A, like we just spoke, you have skills. And skills has a first class concept of examples. So this is much tidier. This is much neater. In fact, you don't even talk about functions. You're just like, hey, I just have one API, send task. You give me whatever you want. And these are some examples on what you can do with me. What you can do with me. That doesn't sound right. Cool. Sweet. That's the capability discovery. I hope this makes sense. There's one more thing I want to highlight. Let's say in an MCP server, we have something called create task, and it takes a project and a task. Okay. Let's say I have an MCP server which takes 2 arguments. Now, what if the user's original question was like, create this task, and they do not mention a project? What would happen? Think about that. What would happen if the user shows intent to call a particular tool, but doesn't give you all the inputs? In that case, your client, this guy, would have to be smart enough to say that, okay, to call this MCP tool, I need some more input. So I need to ask for more input from the user, right? The client would have to be smart, saying that, okay, you know what, to call this MCP tool, I need 2 parameters. The user's question just has 1 parameter. So I have to go back to the user and say that, hey, user, you need to give me some more information. So there's a lot of intelligence which has to sit on the MCP client. And we'll talk about intelligence soon. Intelligence is going to be a very big one. I hope you get it. The point I'm trying to convey is, in case of MCP, it's the client's responsibility to populate all the parameters to be called. In case of A2A, you can literally pass it everything. You can even give it an incomplete input. You can technically still give it an incomplete input and it would still work, because A2A has built-in mechanism where the agent will ask you for further clarification, right? So your client doesn't have to worry about it so much. Okay, important point. And the biggest point I want to highlight here is, in case of A2A, intelligence moves from the server to the client. So intelligence mostly on the server. Mostly. I'm not saying your client cannot be intelligent. I'm saying in most use cases, like 80% of the use cases, your client are not going to be as intelligent. Your servers are going to be more intelligent. So your client will just be like, hey, the user asked me this question. Can you give me an answer to this question? So the client is just like passing things around. The server will be like, wait, I need more clarification. The client will be like, oh, you need more clarification? I'll just ask the user for more clarification. So the client is just like the middleman, you know? It doesn't have a lot of intelligence. I'm not saying it cannot. It can. There could be use cases which demand it. But mostly the intelligence will be on the server. For MCP, mostly the intelligence will be on the client. Your client will have to figure out whether there are some parameters missing or not. The client will have to figure out, you know what, we need some more input. Your client will have to even plan what tools to call in what format. So the client is doing a lot more work than an A2A client, right? So in MCP, you need a smarter client. So intelligent is mostly on the client. The servers are dumb. The servers are just like, yeah, I'll do a database call. Yeah, I'll do a create task. But for A2A, it's the other way around. However, again, highlight this. I know I've said this like 10 times already. But for MCP, you could have A2A like semantics and MCP as well. Like I said already, you could have just one tool which says send task. You could have a tool like this over here as well, you know, which is smart. But again, then you fall short. Like what if the input wasn't clear? You'll have a function which gives you back a response saying that actually I need more input, right? So the function response for this in that case would be, wait a minute, you did not give me the project ID, give me a project ID as well, or give me the project name as well. But now the client would have to be smart enough to say, wait, the answer I got back is not the final answer. It's actually a prompt for asking something more. So again, even if you try to move intelligence to the MCP server, your client will still have to be smart enough to understand that, hey, you know what, the response I'm getting back is actually not the answer, it's a follow-up question. So you can make A2A using MCP. I'm just saying it's really convoluted to do that. Does that make sense? Explorer brings a point that what if I have an MCP server to do research? So it essentially takes a research, it takes a user prompt, it does research and gives back an answer. So Explorer is arguing that the server needs to be intelligent in that case. However, I would argue, let's take a real world. Let's try to extrapolate it and, you know, add some more features to it. Let's say your researcher agent first plans, confirms the plan from the end user, and then does the research, right? I think that's how Google Gemini does its research, and I really love it because it shows me the plan and I can iterate on the plan and then actually do the research. I like it. Let's say you want to add that feature, right? In that case, you would have to create two tools. You would have to say, okay, first I want a research plan. Then you would have to say research. But your research plan will also have to be smart, because what happens if you give back a plan, but the user's like, I want to iterate on the plan. So your plan will be something like this, I guess, right? That, okay, what was the past messages? Like a message array or something like that. That, okay, this was the initial plan. Then the user's asking a follow-up question. So, I mean, you can do it. You can model all of that conversation. It's just so convoluted. And then obviously, once your plan is done, then you call the research, right? So I'm saying you can do it with MCP. I'm just saying that there's a lot of back and forth happening, and there's a lot of modeling which will have to happen, and you have to create these layers, right? Which is annoying. I am arguing something. I'm arguing, don't do that, okay? Just have a get tasks. In your example, I would do this. I would have MCP server. And what would this MCP server do? This MCP server would have some tools. Google search, knowledge base search. That's it. That's what my MCP server would do. I would have an A2A server saying I have a skill, because remember we have skills here. So I'm just writing it out. So we have a skill, MCP server tools and A2A server skills. I would say I would have an A2A server with skills, and I would say my skill is what? I do research. And I've got some examples. Find me research papers on something from Google, right? You could have another example saying, again, remember, example is a part of the official spec, okay? I'm not making things up. This is part of the spec. I could have another example, answer this question from my company knowledge base. You see the difference here. So over here, I'm saying, hey, this is a skill. I do research. I have these sample things. I can search from Google. I can search from knowledge base. And this server internally would be using MCP tools to do the Google search and knowledge base search. Again, I'm saying this server could be an MCP server, but A2A just seems like a better way to do it. Because A2A has, you know what, we're getting into the comparison ahead. My job is to prove why A2A is a better way to do this. So instead of having this research as a tool in an MCP server, I'm going to argue why the A2A server needs to be a skill. So the research thing should be an A2A server, and why these things should be MCP tools, right? That's the argument I'm going to make. But still, the point is that an MCP server can be smart too. Client mostly discover, and then you have a router on the client. Yeah, that's right. You could have smart MCP servers too. That's why I use the word mostly. So intelligence is mostly on the client. That's what I recommend. But yeah, you could have some edge cases where your MCP server really needs to be smart as well. Why not? I mean, you want to do it, you can do it, right? If we don't make MCP servers which are smart, A2A will eat MCP servers for lunch with the A2A protocol. That's precisely what I'm going to argue. I'm going to argue that any MCP server which had intelligence, which was using an LLM, should and will be replaced by an A2A server. That's my hot take, and that's what I'm going to prove in this comparison. It's opinionated, but hey, that's my thing, okay? What's the point of MCP server if you could make A2A server with similar task? Because A2A doesn't have the schema approach. There is no way in A2A to say that, okay, you know what? I need an input with these precise things. So if you want to do a Google search or something like that, these parameters, A2A has no way to describe the schema for those parameters. A2A could add that in their specification. Technically speaking, they could add capability called tools in their specs, but they haven't. Maybe it's to cozy up with MCP or not. I don't know. Currently, A2A has no way to give structure to define schemas for inputs, which means if you want to call a database, if you want to do any kind of structured tool call, A2A literally has no way to do it. There is no way to enforce a schema in the A2A protocol. So for tools, unfortunately, you just have to use MCP because A2A chose not to implement it. It could, it chose not to do it, right? So you still need MCP for that reason. But okay, let's keep continuing. We've already given the end answer at this point. So now the stream has become like, instead of arriving to this conclusion, we are going to prove why is this conclusion a better conclusion. Oh my God, we just flipped the stream over. You guys always do that to me. Like my flow just goes for a toss. I mean, okay, cool. Yeah. So the next point I want to say is the task scope. So again, just covering what we already discussed, I'm going to actually put it up here. We already discussed this. Because the skills are so broad, the scope of A2A is not well defined, right? You're just giving examples. So you're not really restricting the scope. You're just like, hey, I have few examples, stick with it. But there's nothing forcing your client to stick with it, right? In this Notion A2A server, the client could technically say, give me the scores for tonight's baseball game. I don't know. It could do that. There's nothing stopping it. In MCP, there is no tools to get results of a baseball game. I don't know even why I'm saying baseball. I don't even watch baseball, but okay. In MCP, the scope is restricted to get task and creating task, right? In A2A, there is no such way to do that, which means your server is going to be complex. You need guardrails. In A2A, clearly, it's very well defined. I think one more thing goes in that in MCP, input strictness. And I think you'll also get my thought process on like, how am I comparing these things, right? So input strictness, not strict at all. It's multimodal. I mean, it's free flow. Do whatever you want. Mostly strict. I also had mostly over here because I know we can have smart MCP servers, man. I mean, you could technically have smart MCP servers. Why not? I mean, you could do it. But mostly it's going to be strict, right? Because you're defining the frigging type of every parameter you want, right? So it's as strict as it gets. This is a function call. MCP is just RPC. It's remote procedural calls. Okay, now we are gonna get into the big stuff. So right now I've just been stating some low-hanging fruits. I'll get into justifying this now. So now comes a heavier portion. So I want to take a pause here. Now I want to get into some big differences on why A2A servers should be intelligent. So I want to focus on this. Why intelligent servers should be A2A and why dumb servers should be MCP. Okay, that's what we need to get at. Let's start with the obvious point, which if we've already covered, I'll just reiterate it. If you have an MCP for Notion, right, which just get task and create task or whatever, somebody has to make a plan. So let's take a simpler example, which I think a lot of people have seen out in the world. Let's say you have an MCP server for a database, because who isn't doing this, right? Nobody's doing this. Nobody's building MCP servers for databases, right? I mean, that's absurd. Who would do that? I'm kidding. So yeah. So let's say we have a database, okay? And your database has a couple of tools. So it has a tool called getSchema and it has a tool called runQuery, right? So getSchema gets you the schema of the database. runQuery takes a SQL query and runs it. The MCP client, the client which is sitting here, would have to be smart enough to first decide that, you know what, first I need to get the schema. Based on the schema, I need to generate the query and then run the query. Something like that, right? No matter what your MCP server is, you'll always need some kind of intelligence. Now, like also we discussed, you could have something like this. You could have an MCP tool, which is essentially run natural language query. In this, it seems like the client is becoming dumb again, right? Like it can just do this. Correct? It can just take the natural language and pass this. And this works. Don't get me wrong. This works. You could have an MCP server which, gets the schema, does all that fun stuff and, then calls the database. So yeah, you could technically have an MCP server which does this. But once you start getting into the real world examples, right? And you figure out something like the user's asking a question about tasks, but there is no table called tasks. Now, this tool will suddenly give you a response back saying, wait a minute, know what table you're talking about. Did you mean this, right? Something like that. Wait a minute, I don't know what you're talking about. Did you mean this? Or maybe the MCP server says, okay, I want to run this query. Is that fine, right? So, or it could be like, because it's a read query, here's the results of the read query. You see what just happened here? We're breaking it down. So either we could have a situation wherein if it was a read query, we directly get the result of the query. If it was a write query, then we say, hey, we want to run this query. Is that fine? And if you give me some very stupid query, then I'll be like, hey, I don't even know what you're talking about. Are you talking about something like this instead? How do you model this? So the moment you get a response back, now your client will need intelligence, because your client will have to say, wait, the response I got back, is that response a final response? Is that response something the human has to confirm? Is that response something I need to iterate on myself? How do you know? You need intelligence just to understand whether the task was completed or not. And now again, you'll be like, but wait, I can have a separate tool for write queries, a separate tool for read queries. Again, you'll have to decide which tool to call and your client becomes intelligence. The point is, because MCP is just a request response format, the client will either have to pay attention to what tool to call. You'll need intelligence in figuring out what tool to call, or you will need intelligence on how to parse the response. So you'll need intelligence for one of these two things just because of the nature of MCP. Again, I'm not saying having intelligence on the client is a bad thing. I'm not saying that at all. I'm just saying that this is an additional step you'll have to worry about, right? You'll have to worry about figuring out which tool to call, or you'll have to worry about interpreting the response. It's not clear. Let's see how A2A does this. And A2A has a really good example in its specifications. I'm just going to write that. And then if you want, we can extrapolate it further together. Let's say we have a question saying that, okay, request a new phone or run this query, whatever, right? Multiple things can happen. So okay, wait. Sorry, I need to backtrack because I know this is a new video, so we did not speak about it. So let's speak about this first. In MCP, you have something called tasks, right? So you submit tasks to users. Again, if you want a detailed deep dive on the A2A spec, check out my previous video. But essentially, you submit tasks, and task could be like anything. It's natural language, it could be an image, it could be anything. So you essentially submit a task, right? Now, the server might be able to finish that task for you straight up. Right? If it's a read query, it could finish it straight up, or it could be like, wait, I have some more input to ask you. Correct? So let's say in this case, there's more information to ask. So now what happens is the server tells you back that, hey, wait a minute, input required. There's an explicit message called input required, or there's an explicit state called input required with a very precise question. So A2A is explicit. It's saying that I did get something back from my server, but it's not a response. You don't have to figure out whether I got the response or not. It is explicitly saying, hey, you know what? I need some more input, and this is where. Now, I could have a dumb client which could just take this and give it to the user directly on the UI, or it could be a smarter client which uses intelligence to do something fun. Again, there's nothing wrong with intelligence on the client. I'm just saying you don't have to figure out whether the task was complete or not. So obviously, let's say, our client is dumb in this case, so it just spits it on the user, and the user just types in Android on the UI, right? So again, so you send this question to the server. Again, you're just submitting the task against the same task ID. So you're continuing a conversation with the server, right? So you're just saying, hey, I want to continue the conversation with the same task which we just started with earlier. And I'm just saying Android. Again, I'm not giving anything else. Remember, it's like a conversation, so I don't need to be explicit. I'm just answering this question. Now the server says state is completed. Very explicit, extremely explicit that, hey, I'm done. Now I have an answer. We are done. Okay. And it's not giving us a message back. Remember, in the earlier thing, it was giving us a message back. It was saying, hey, this is my response to the task. My status is input required, and I have a message for you. I'm conversing with you. I am participating in a conversation, or I'm collaborating with you to complete the task, right? So a message is a collaboration. However, once your task is done, you get an artifact. That, hey, order confirmation. So we have an artifact called order confirmation, and you can have some details. If you are generating an image, the artifact would be the image. If you are creating a task, the task ID could be the artifact. The point is, once you get the artifact, you know for sure that, hey, things are done. I have an answer. Now I can be dumb and just show this to the user, or I can use this to make a decision, call another A2A agent or whatever. You see how explicit A2A is. The agent has first-class capability to request for additional input. And we saw that in our example as well. When we were trying to schedule some tasks with the calendar, essentially what was happening is the calendar did not have a 4-hour block free. So it asks a question. It sends back a message saying, hey, I need some more questions. Again, the user could just, take that and handle it directly. But in our case, our assistant was intelligent. Again, there's nothing wrong with intelligence, right? The assistant was intelligent and said that, hey, if we don't have 4-hour task free, we can just ask Notion to break that task down. How does it know that Notion can break that task down? Because in Notion's skill, there would be one example which states that, you can give me a task and I can break it down for you. So the assistant doesn't need to be like an extremely good planner. Notion's skills or the Notion's agent card will be explicit saying that, hey, you can break things down. So yes, you have intelligence in this case, but you know exactly when to use that intelligence. It's very explicit that input is required, use some intelligence to solve it. If you cannot figure out a way out, then ask the user, whatever. And once the task is actually done, you get an artifact back. So in this case, you would get an artifact back and now it's done. Again, A2A allows you to follow up on artifacts as well. That's another conversation. Check out the previous video. Cool. So the point I'm trying to make, support for collaboration. What does A2A say? Hell yeah. That is better. I'm just enjoying myself today. I'm having fun on this stream. What does MCP say? Yeah, but you gotta do it yourself. Like you'll have to architect the tools and stuff yourself. So it's with an asterisk. You can do it. It's not as seamless as A2A. Okay. And this collaboration is a big one. Not just that, this is something for me. So the point is, whenever you have intelligent agent, that means there's an LLM somewhere in the middle, right? And again, for a good experience, if you're returning the LLM's output to the user, you want to stream the output, right? So a good user experience requires streaming. Like as the response is being generated by the server, you want to see it be typed, like how we see it with ChatGPT for that matter, right? So in that case, what can happen is, again, MCP supports streaming, just how you would stream with OpenAI spec, just say stream true. And the best part is, again, it's so frigging explicit because in your agent-to-agent card, the agent explicitly says, I support streaming, right? Which is great. So instead of submitting a task, now you say, I want to submit subscribe. And then you could just say, hey, this is some response I want from you. And now instead of saying completed, the server sends back a status of working because again, it was send subscribe instead of just send task. And now you're just getting your stream back. And it's so cool. Just look at it. It's saying that, okay, the answer I'm going to give back is finally an artifact. So it's not a follow-up question. It's directly an artifact. This is my section. Don't append this. Because remember, when you use OpenAI streaming, you get delta chunks back. So you need to append it on your own end and things like that. But some servers might give you the entire response back. You don't need to append it. So here the response is explicit. It's saying that, okay, this chunk, don't append it, meaning this chunk gets replaced. So whatever you had in your buffer, replace it with this. And then when you get the next chunk, you see here it's append. So now what it's saying is that this next section needs to be appended to your previous array. So you're adding it. Again, if the append was false, in that case, you would replace it with your previous array. It is so explicit. So it's giving you best of both worlds. It's giving you a place where if you want to stream delta, you can stream delta and just the delta chunks and just say append true. If you want to stream the entire thing over and over again, because maybe you're streaming JSON and for JSON, it's better to stream the entire JSON over and over again, then make append false. It supports both the scenarios and it's so frigging explicit. I love it. And then it says obviously that, hey, this is the last chunk, so we are done here. Right? So it's streaming. But a problem with streaming is, what if you had a network problem, right? So what happens then? A2A supports resubscribing as well. So you could say that, hey, you know what? I disconnect from the previous task and I just resubscribe and it's going to be like, yeah, sure. I mean, let's resubscribe and it's going to continue from where it left off. Now, again, the nuance here is that the server would have to send the original chunk again. So that's a server nuance, which is not really documented. But I'm assuming most servers will start streaming everything again, all over again, right? They won't just continue from that instant. They will stream the previous thing again. I'm assuming. Or the server could be like, oh, I remember that the last thing I sent you was this, so I'm going to continue from here. Again, I would suggest that the server sends everything. So the first message server sends back will be append false, which means replace. The first chunk, I'm sending you everything again. And the subsequent ones will be append true. It's so flexible. This is what a thought of specification look like. So the answer here is nope, we don't support it. There's no streaming support in this. Technically, MCP does have support for something called notifications, which could be used as streaming, but it's not a standard protocol, right? Your client doesn't know whether it supports streaming or not. The client doesn't know if it's going to give the response directly or it's going to use notifications. There's no clear indication on how notifications work, so I don't think anybody's going to be using it. So yeah, streaming, I'm just going to call it a no. And A2A takes a hit in that one. And chances that an intelligence server requires streaming is high. Again, if you're using intelligence to, do a database call and return back the database call, you probably don't need streaming. But if you're returning back an LLM's response, you do need streaming. I mean, I would argue even for a database call, like if this was an A2A server, you could stream back each result from the database one by one. Right? You can keep streaming that one by one. So again, it looks good, I think. I don't know. I just think streaming is a very good thing for user experience. And talking about user experience, we need events. So in this entire thing, remember, because our user is a monkey, we need to tell the user that, hey, something's happening. So you can do that. So for example, you want to tell the user that, hey, I just got 2 tasks. Hey, you know what? I'm trying to schedule things now. Oh, we got a problem now. Hey, we are trying to break it down. Hey, it's done. Giving updates to the user so that the user knows what the agent is doing. And obviously, if it's an agent, it's multi-part processes. It's going to get the schema. It's going to write to the database. There could be multiple steps involved, right? Keeping the user in loop of what is happening is really important. Like cursor on the right gives you, or wherever your agent tab is, on the agent tabs, it tells you, hey, I'm reading this file. I'm generating this code. It's good to know what it's doing. So if it's going on the wrong track, you just cancel it, right? And yeah, A2A supports canceling as well. So in A2A, you can technically cancel. I'm going to just add that as well. I'm so sorry. There's just so many cool things about A2A, right? So like, again, in Cursor, if the agent is giving you events and you're like, hey, the events don't make any sense, you can just cancel it. In MCP, you cannot cancel squat. So MCP has no concept of steps. So if this step was doing 10 steps under the hood, it cannot send intermediate steps. I mean, there is again notifications, but it's really complicated to do that. So I'm not going to talk about that. So in A2A, you have first class support for events, which means if you want to cancel it midway, you can actually even cancel it midway. It's just easier to do. I'm just going to write a note here. The last thing I want to just highlight is, so yeah, it has events. And the server can explicitly say, give it back events saying that, hey, I'm doing this, I'm doing this, I'm doing this. The spec already covers that. And it's also explicit whether the server supports doing that. And as a client, you can also say that I'm not interested in those events. So you don't have to receive those events. You can request for those events. And you can even see if the server supports sending events, right? So it's very flexible that way. You can cancel running task. You can do that as well. You'll also call something called notifications, which is a really cool feature, wherein you can say that an agent was trying to create a YouTube video and it takes like 2 days to make it because it's a long running process. So A2A has first class concept to say that, send a webhook with the video, right? So technically A2A can send a webhook whenever an artifact is ready. Technically, as a part of the protocol. So the client can say that, hey, you know what? I know you're going to take a lot of time, so don't give me the response of the task here. I don't care about it, okay? Just take this task, do whatever you want, and I'm going away. And the client can say, once you're done, and the client will, before going away, it will be like, hey, server, before I go, remember, once you're done with the artifact, can you give it back to me on this URL? And the server will remember it, and as soon as the task is done, the server will call that URL. So the client can explicitly tell the user to submit task status changes through webhook. In MCP, I mean, this is custom. You can do it, but the protocol doesn't support it, so I'm just going to call it a no. I mean, you can build it yourself. You could have a resource where you say that, okay, all artifacts should go to this URL or something like that. You can use resource and things like that to kind of configure these kind of details. Again, it's just, you have to do a lot more work, right? Hopefully that makes sense. Okay, there is a lot of stuff here. A2A, talk to other agents, collaborate. Yes, MCP, use tools. Precisely. I think that's the perfect place to even end things, right? So the conclusion would be A2A allows for intelligence on the server. So whenever you want to create a server and you think you're going to use an LLM there, A2A would be a good bet. You can do it with MCP, but eventually you'll run into this problems. Like, what if you want to collaborate? What if you want to ask user follow-up questions? What if you want to stream? What if you want to have events? MCP currently does not support those things. So if you're having an LLM on a server, on an MCP server, you're going to lose out on these features, which is a little annoying. A2A does that really well. But A2A is a complex protocol. So if you just have a server which does things like these, A2A would be an overkill, especially the fact that it can't even support these things. Let me know, how are you planning to use A2A? Let me know if you agree with what I said, right? especially when you plan to use A2A and when you plan to use MCP. I just want to know different use cases. And remember, I stream every Tuesday, so I'd love to see you there. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech boy. You're on YouTube and hopefully in real life.